So this year or so, I decided to create another back to basics talk, since it's very useful for beginners getting into Yocto, and especially in some very complicated topics like the one that I'm gonna present today, which is the story of Yocto Toolchain. So whenever I'm teaching Yocto, always students ask me how BitBake, what's the magic behind BitBake knowing exactly how to prepare binaries or applications for our target. So from that, I got the idea that I need to dig into this and make a uh, simple presentation and try to make it as simple as possible, because it's not very simple topic to present always. So before starting with this presentation, just a quick word about myself. I'm Talel, and I'm an embedded Linux engineer and a Yocto trainer. I'm from Tunisia, North Africa, and currently I'm working for Sagem.com, and I have a Discord server called TakeLeaf, which is my purpose is to its purpose is to um, provide support and teach people, especially the Arabic community, Yocto build system for free. There is also a YouTube channel called TakeLeaf. Next week, I will start I called it From Zero to Hero Yocto course for Arabic community for free. So if you know, if you have a friend, you know, someone from Arabic community, Tunisian, or anyone else, you can tell him about this. So let me start. So first of all, what is a tool chain? This is very simple presentation about a tool chain. So basically, you have a target and you have sources. So main thing you need to think about is what are the specifications or information about your target. For example, what is the C library used in that in the system running on the target? What's the operating system? What are the features of the CPU of the target? For example, does of course, first thing you need to know is the architecture of the target and whether it has an FPU or not. This is not the full list, of course, but you need to make sure to know as much information as possible about your target in order to create a tool chain that provides binary that are guaranteed to work on your target. So you have a compiler and package or collection of utilities that we call binutils, the assembler, linker, readoLF, and many other utilities that are used to manipulate or create link ELF files. Now, compiler binutils called the toolchain, and I usually think about the toolchain, which is a chain of tools that are used to complete the compilation process. Of course, this is utilities. You need C library, other libraries, other tools as well in order to create the full SDK. So this is how usually I think about look at the tool chain. So binutils, just utilities that are used on binaries. Toolchain is a chain of tools, and SDK is just a full kit that you use to develop and compile your software for a specific target. So this is now what I call the three-where question. First question is, where will the toolchain be built? This is we call the build part. Now, where will the toolchain run? This is the host. And where will the output binaries run? This is your target. So if they are all equal, this is we call native, and this is the cross type. which is the host, is different than the target. Now, if the build is not the same as the host, this is a cross-native, and if they all not the same, this is what you call Canadian or cross-Canadian. Of course, I will present more details about all of these four types, especially how are they are all related to Yocto. So going to Yocto Toolchain. Now, this is the part that one of my students taught me about, and he said that why there is 1,000 GCCs in Yocto, and I said, what are you talking about? So when he sent me GCC cross Canadian, GCC cross SDK, and all the different classes used, like native SDK and cross SDK, I understood what exactly he's trying to figure out. Just you want to understand how they are all of these components related, why there is different variants of GCC itself. So that's the main reason why I'm making this presentation today. So the default configuration is called target, which is if you have a recipe that you want to install that recipe, create a package from a recipe, and you want to integrate the package in your board, for example, your target. So since it's called target, your target board or target machine, the default configuration is always that your recipe will provide a package that will run on your target. So this is how I will present different elements that essential to BitBake in order for BitBake to know what type of compilation it needs to do for your package. So these are basically different architectures that BitBake will use. So you have the build architecture, which is the architecture of your build machine, host architecture, which will run the created toolchain, your target, the SDK machine. We will talk a lot about SDK machine, which is a machine, the architecture of the part that will run the SDK that you can populate with BitBake. And you have package architecture, and you have tune architecture, which is basically your CPU architecture. In most cases, your target architecture is tune. So now we will go step by step into the different types: native, cross native, and Canadian, and see how all of these elements are related based on the type. So of course, all of these elements are just based variables that are have default values set by bitbake.conf. Okay, so for example, bitbake.conf includes your machine configuration or SDK machine. Also, it sets your class variant to class target. This is a default configuration. Of course, class override variable goes into the override, so you can use class target to override variables or tasks. So the default, the SDK machine is the same as the build architecture. This is the default configuration set by bitbake.conf. And your target architecture is set to the tune architecture and package as well. And host is the same as the target. So this is the default configuration. Now, everyone knows the depend variable, which you can use to specify compile time dependencies for your recipe. So the default configuration for depends is the compiler itself, compiler libs, and the C library. And this is set by the base BB class. Only if you do not set the inhibit default depths variable to 1. And as you can see, the base default depths variable is set to virtual/host prefix GCC, And as we are in the default configuration target, which is the host, is the same as the target. So that's why you have host is the same as the target. So the target, which is in this example, is R64. So depends default value for depend is virtual slash R64 Poke Linux, in this example GCC. So we need a recipe that provides this package now in order to be used by any target recipe. So GCC cross is what provides virtual slash R64 Poke Linux. Now we need to know what's the meaning of this cross type. So moving to native and cross variants. So the cross BB class, so going back to the same elements to see what will be changed here. So class override will be changed to class. This is definitely wrong. This class cross, I think. Go, never mind. So for the class BB class, the target stays as it is. SDK machine is the same as the build. Now the host architecture is changed to be the same as the build. This is because we need to build something on the build system that will run on the same system that will provide something for the target architecture. This is the cross variant. So this is basically used to prepare the toolchain, cross toolchain that will be run on your same build system and provide packages for your target machine. So this step here is when BitBake will create a toolchain, specific toolchain from scratch for your target machine. So this talk is not about how toolchain is created, but you can check this very good presentation by Thomas about how toolchain is created and how the compiler is actually built for a specific target. So if you have for example, a recipe called hello, which is it will go to the target machine. Now GCC cross will provide a tool chain. In this example is R64 Poke Linux that will go into the recipe sysroot native of your recipe. Now your recipe will of course, the recipe sysroot native will be added to the path variable of that recipe that will contain GCC cross compiler, G++, and all the rest of the toolchain utilities. Now your recipe will set the CC variable. For example, this is just an example. CC variable to use that cross compiler that is provided by GCC cross. So as I said, hello, in the default configuration, the variable depends has the GCC cross in it. So yeah. So moving to the native class, getting back again to the elements. So this class override will be class native, and everything now will be the same as the build arch. So this is, as the name states, we need to build something on the build system that will be run on the build system. So, and native packages or native recipes are used by BitBake to produce something that run on the build system that will help BitBake creating your target packages. For example, virtual bootloader depends on DTC native. So if, for example, we get the value of depends of virtual bootloader, we will get DTC native in there. And if we dig deeper in this, just quick find on the staging dear native, which is recipe sysroot native of the virtual bootloader recipe, we can clearly find the DTC binary in there. Now, getting into the real horror movie that my friend is talking about, which is native everything that's related to the SDK. So this all starts when build and host and target are all not the same. So we need to use the native GCC that runs on your build system to build another GCC that runs on another architecture, which is we call host. But that second GCC will produce something for a third architecture, which we call target. So the host in this case is called SDK machine in Yocto. By default, SDK is generated for the same build. So let's take an example. I meant to say x86-64, but you get the idea. So in this example, I set SDK machine to R64. Machine is to QEMU RISC-V 64, and my PC is x86-64. So this is a very interesting case to study how BitBake will behave when generating SDKs or dealing with the recipes. So this is the big picture. So you have a build system that has a GCC that will run on x86 and generate something for x86. We need to create another GCC that runs on x86 and produces something for R64 because our SDK machine is R64. So this is basically a cross-compilation, cross part. Now we have another build system. So we have the same build, but we will use the same GCC built in the first step that provides something for R64. Now we will use that compiler to create another one that will run on R64 but generate something for RISC-V 64. So that's the host that will run the final compiler that will produce something for the target. So the target is different from host and build. So this is Canadian. So if we combine these two together, we get the cross-Canadian variant of Yocto. So the cross SDK, which itself inherits the cross class, going back again. So this is our example. The build is x86. The tune architecture, which is the final architecture of our target, is RISC-V 64, and our SDK machine is R64. In the cross SDK variant, the host is the same as the build. As this is the same as this diagram, but showing how the elements related based on the cross SDK variant. So this is the first part, which is cross. That's why cross SDK inherits cross. So in this step, we will set the target the same as SDK machine. So this is temporarily in order to make forced BitBake to generate a compiler that will run on the target. Now this target is temporary, which is the SDK machine, not the final target. Now, why using cross here? To prepare a new compiler that runs on build and produces for the target. Now, the target is the SDK machine here, not the final one. We don't want to build simple applications that run on the target SDK machine because the real target is not SDK machine. We need just to build the true toolchain that will run on the SDK machine, and we need to prepare a toolchain that runs, yeah. So now moving to the second part, which is cross-Canadian, the final part. Now, after preparing a toolchain that will run on the SDK machine, now we set back the target architecture to tune, and host will be the SDK machine now, because the host is what runs the toolchain. So the SDK will run, we will run the toolchain on the SDK machine, and package arch is the same as SDK machine because we need to provide packages that run on the SDK machine. So I said we don't want to build simple applications that run on the target, which is SDK machine, because the real target is not SDK machine. But if what if we want to do that? What if we want to create a package, create an application or binary that will run on the SDK machine or on the machine that will run the SDK? But we want these applications to not provide something for the final target. We want just an application to run on the SDK machine. So this is what native SDK class is for. So we just set the target architecture to the SDK machine. In this way, with the host set to SDK machine, we make sure that the toolchain needs to be run on the SDK machine. Also, the target architecture needs to be the SDK machine. So this is like a native, but not like for the build, but for the SDK machine. So moving to very important notes in order to fully understand the toolchain story in Yocto. So there is a variable called BB class extend. It's used to extend the use of a recipe. For example, if you have a target recipe, you can extend that recipe to be native without explicitly inheriting native. Because if you explicitly inherit the native BB class, of course, you will change uh, um, you will set the recipe to be native, but in most of the case, lot of cases, you don't need to do that because BitBake will, if it finds BB class extend that you have, for example, BB class extend native, BitBake will just copy or create a native variant. So it will create variables for that native variant. It will override everything for the native variant for you. So you don't need to do that. Only if sometimes it cannot. Sometimes you will find yourself when using BB class extend native, it will not work as you intended. But in that case, you need to manually create a native variant. So you copy your recipe, you add native to the name of the recipe, and you adapt it to be built for your native system, your build system. So there's another very important variable, which is TC mode, which is the toolchain mode. So the default toolchain configuration is default. This is set in the BitBake main BitBake configuration file. So BitBake requires conf/distro/include/dc mode, and now the variable tc mode include file. So the default configuration file exists, and the default configuration file is what sets the preferred provider for the compiler, binutils, and all other necessary recipes or packages for creating the tool chain. So BitBake, after loading or parsing the TC mode configuration file, it will know exactly what compiler binutils packages needed to create the tool chain based on other variables that we saw earlier with the build arch and target host and SDK machine. So this is an example. So we have GCC cross recipe that provides virtual/target prefix GCC, for example, and it sets its package name to GCC cross target. Now in the TC mode default, which is the default toolchain configuration file, it sets the preferred provider for that virtual target GCC is GCC cross. And with this, BitBake now knows what GCC it needs to use in order to prepare the tool chain that will be used to build the target packages. So in this way, you have a hello recipe, for example. The hello recipe has the depends variable set by default to virtual slash host prefix. And in the default configuration, which is target, the host is the same as target here. That's why this will trigger BitBake to look for the virtual target prefix GCC, and using this preferred provider, it will go to the recipe that provides this one, which is GCC cross, and this is the GCC cross.bb recipe, and this one inherits the cross bb class, and now everything starts with the cross compilation and preparing the toolchain, cross toolchain that will run on the build system and provides produces packages for your target. So another interesting topic to talk about is which is external toolchain. So what if we want to use an external toolchain? We don't want BitBake to create a toolchain from scratch. So BitBake supports this. So no need for BitBake to generate a cross toolchain, and target class recipes can be built directly. So no need to prepare a cross toolchain. We can directly use our external toolchain to cross compile our target packages. But Canadian toolchains still need to be generated using the cross one, because this is just we just provided the first part, which is the cross toolchain. But if you want to use that external toolchain on another machine, which is we call the SDK machine, that will not work, because that will work, of course, if your SDK machine is the same as your build system. But if it's not the case, you need to generate the cross Canadian variant yourself. So as an example, you have Meta ARM toolchain, Meta Sorcery. You can take a look at those after. So the big picture of external toolchain. So you have your layer that has conf distro include TC mode external. For this is an example, external ABC. In this configuration file, we set an external toolchain variable that points to our native path, and we set preferred provider. Now the preferred provider for GCC is our external ABC toolchain, which is a recipe that provides everything. Now we need one recipe that provides everything, GCC, binutils, and all other utilities needed for that defines the toolchain. And in our local.conf, we just, or any other configuration file, we set the TC mode to external ABC. Now, this is final note, I think, which is about Yocto SDK. So for example, if you have an image, let's say core image minimal that has list of packages that will go to the package install variable. Now package install variable in BitBake, I think this is set in the image BB class. This will be added or appended to the toolchain target task variable. Now there is another one variable, which is toolchain host task, that has this default value, which is native SDK package group and package group cross Canadian. So this variable contains all packages that will go, it will be embedded into the populated SDK. So we have two types now of packages. So we have toolchain target task, which are recipe or packages that will go to the SDK, but are just meant for the target. They're not meant to run on the SDK machine. And we have the toolchain host task that will have the native SDK that will run on the SDK and provide something for the SDK machine. And cross-Canadian package group, essentially it contains the GCC and C library and the toolchain main components that will run on the SDK machine, but uses also the toolchain target task packages to link or to do its job to provide something for the final target. So if you have a package, for example, you can add this package to the package unstyle variable and do populate SDK again based on your root file system, or you can add it directly to toolchain target task if you want your package to be just included in the SDK and not in your image root file system. So Clang support, yeah, and here we go again. Yeah. So this is, I will not go through this. So this is basically the same, and you got the idea. Any questions?
Thank you. Very interesting. We had a lively discussion in the chat talking about what you were presenting. Did anyone have any specific questions? Go ahead and unmute.
Yeah, this very complicated topic. It needs it needs more time to present a lot of details that for sure will make things more clear for everyone.
Yeah, there was the debate. What was the difference between build, host, and target? We got a couple answers, and how Yocto project differs from some other communities and how they define those three terms.
Yeah, I noticed this also. Yocto has a special defines or understand defines another meaning sometimes. For example, in the target configuration or target variant, it sets the host the same as the target. And generally, other communities use cross meaning and set target target and host not the same. This is cross type, but in Yocto this is not the case. For the target configuration, they set host is same as the target. We need to dig deep into this to understand, maybe because yeah, Raj says when build equal host, then there is no need to set build.